Hey guys, welcome back to Data Products. In this video we're going to be going over error bars. Error bars are really important because they are ways to show if your data is statistically significant. Two ways you can do this is to use standard deviation or the standard error. Standard error is a little better proxy of what is considered significantly different, because if the error bars don't overlap, then generally most of the time there's statistically significant differences between the two. So with that said, let's go ahead and get right into it. Okay, let's start off by opening up our RStudio, and let's do our markdown. We'll call this error bars. Okay, and we're gonna cut this out. All right, first let's load our required libraries. So we're gonna be using a couple for this. Library, we're just gonna load them at the beginning. ggplot2, library dplyr, and library plotrix. Let's set our theme. I'm just going to use classic for this. You can use whatever you'd like. Legend position, I'm going to say top. And that is it for that. Let's run that. Okay, let's again use the tooth data for this exercise. It's a nice small data set that we can easily navigate and understand at this point. So our data frame is going to be tooth growth, and we got to change our dose to a factor because we don't want it to interfere with our analyses if it thinks it's a number, because remember it's like 0.5, 1, and 2. Okay, now let's use dplyr for manipulation purposes. So df summary, we're going to create a new data frame where we have like summary statistics, and we're going to pipe it down. We're going to say group by, and we're going to group it by dose, right? Because we want each of the three doses statistically to have their own, to tell if they're different, right? We're going to use summarize, where standard deviation is equal to length, NARM equals true, and then we have length equals the mean of length. So we're saving, we want to keep the name length, so we're saying replace all the length measurements with just the mean of length. It's not always the best way to do it, but this is the second time I've tried to record this video, and the first time I made a change on the fly and it messed up all my code. So we're just going to do it this way. And then we're going to say standard error equals std.error, which is from the plotrix package of length, and na.rm equals true. So that's going to give us our standard error. All right. And actually, let's add to this df.summary so we can see what we have. Oh crap. All right, so you're gonna have to rerun. See, this is the problem with saving over your length data, because we have it. Let's see, what did I do here? I think, let's try putting this above here, because I think the standard error is running after we have already changed length, and we don't want it to do that. There we go. So now we have the right standard error. See, that's one of the problems with saving over your variables. If you do it, it can mess up your code. And so, bad habit, I want to point it out that it is a bad habit, but we're just going to roll with it because, like I said, this is the second time I've recorded this video, and the first time was a train wreck. Alright, so now, let's now look at some key functions. And these are functions that are good for you to annotate your code with, or your data product with, to show significance. So one is geom crossbar, and this is for hollow bars with middle indicated by a horizontal line. And we'll do some of these so you can see, but I just want to show you, or give you a list of what you can do. So error bar is for error bars. Geom error bar H for horizontal error bars. And then geom line range is for drawing an interval represented by a vertical line. And this is good if you're doing like permutation testing. So if you look at some graphs that have like, that do for like genome-wide association studies, where you've done a permutation test to show what the highest possible value for a randomly generated association is, and then anything above that is statistically significant because you did this permutation test. And so that's a way of drawing the line and displaying data for it. And geom point range for creating an interval represented by a vertical line, but with a point in the middle. So that could be like your mean or something like that. All right, let's start by creating a ggplot object. So we're going to start with tg for tooth growth equals tgplot. df summary is our data. Our aesthetic is going to be x equals dose, y equals length, y min equals length len, this should be equals len minus sd, and y max equals len plus sd. So this is just setting how big our x and y axis is. Okay, and so this doesn't print out anything. Remember, we're just storing it in this ggplot object. You can see it's up here. Now let's look at the most basic error plots. It should be error bars. Bars. There we go. Okay. tg plus geom point range, and then tg plus geom error bar width equals 0.2. and geom point size equals 1.5. So these are just basic drawn on error bars where they use the standard deviation. Geom point range. Did I not do? Oh. Y min, Y max, did I not run this? Geom point range. Oh, hold on. Forgot. There we go. It used to be the equal sign. There we go. Okay. So as you can see, we have geom point range, and so the point range, you just have a point with the You standard deviation attached, and for error bar it's the same thing, except it makes those little kind of hourglass shaped figures. So very basic. This is just an introduction. So now let's create horizontal error bars by manipulating our graph. Okay, so ggplot EF summary, or aesthetic, x equals length, y equals dose, x min equals length minus standard deviation, x max equals length plus standard deviation, and then geom point, and geom error bar h for horizontal, where our height is going to equal 0.2, and that should be it. So now, as you can see, where do I have ST? Like plus SD. Here we go. So you see you can do the error bars in the other direction. So if you wanted to put your dose on the side and your length for some reason down here, which you usually probably wouldn't do, but this does come in handy if you have measurements times measurements, right? And you want to show measurements on both axes. Okay, this just gives you an idea of error bars on the horizontal axis. Like I said, I wouldn't graph it that way. It's just not very traditional, but you can do you, I guess. But it just shows you. So there are cases where you would use horizontal error bars. Now let's look at adding jitter points, which are the actual measurements, to our data. Okay, so ggplot EF aesthetic is dose length. We're going to add geom jitter position equals position jitter of 0.2, color equals dark gray, and geom point range aesthetic y min equals length minus standard deviation, y max equals length plus standard deviation. Our data for this, for our point range, is not gonna, it's gonna come from a different source, right? Because with our ggplot object up here, we're saying it's coming from data frame, but all of our statistics are in that summary statistic data frame. So we gotta say df.summary. Alright, let's see how this one turns out. Boom! So now what we do is we have the main, which is the dark spot in the middle, we have our error bars, and then these gray dots are our actual measurements. And so the jitter position, or the jitter position, is how spaced out they are. So they're not all just on this line right there. So it kind of pushes them around so you can kind of see a cloud of them. Okay, now let's try error bars on a violin plot. Alright, ggplot data frame, aesthetic is dose and length. And now let's add geom violin instead of our geom. We used range before. Our color is going to be dark gray. Our trim, we're going to say we don't want to trim. Geom point range aesthetic y min equals length minus SD, y max equals length plus SD, and data equals df.summary. Alright. Boom. Violin plot. we got our distribution. So this is kind of like the same thing as here, right? So we have our distribution of points. So if you turn this 90 degrees and cut it in half, right, down the middle there, then you'd have our distribution of points. You have our mean, and then our error bars. Okay. Now, how about with a line graph? All right, so we got ggplot, df.summary. Aesthetic is dose and length. And geom line aesthetic group equals 1. And I'm going to put a little note here. Always specify this when you have one line to have one group. Geom error bar aesthetic ymin equals length minus, like equal, not minus, length minus, and we're going to use standard error here instead of standard deviation. Ymax equals length minus standard error, width equals 0.2. And then let's change our point size. Geom point size equals 2. All right. Well, that's weird. The way these partial lines. I don't know why that happened. Line aesthetics grouped equals 1 plus geom error bar aesthetic ymin equals length 1 minus equals 2. I wonder if I change this just to SD. My standard error is messed up. Oh, it's because I have minus, ymin is minus, and y1's got to be plus, right? Alright, let's try this again. There we go. So you can see if these error bars overlapped, like if this one was way up here or this one was way down here, they would not be significantly different. But because they don't overlap, we would assume that they're significantly different. So there we have a line graph. Now, let's keep on keeping on. Make a bar graph with have error bars. So this is something that you can do for bar graphs. It kind of makes sense. I would probably still use full error bars, but you'll see if you are going to use it for a column or a bar graph, you'll see why in a second. All right, so colors light gray, or fills light gray. The color is going to be black on the outside, the lines. And then we're going to add geom error bar. We're going to say our aesthetic ymin equals length. Ymax equals length plus standard error. Oh, and let's also add width equals 0.2. And so you can see here, we've just drawn the top side, so you don't see the bottom side, so it kind of looks, some people like the way this looks a little bit better, but it kind of makes it a little bit difficult to compare the overlapping. But if you have very tight error bars, is what you would say for small ones that don't overlap, this is fine. It looks cleaner and you know these aren't overlapping because this would just be mirrored on the bottom side, right? The error bar is just divided in half. But if you have ones that are really close, it might be kind of deceptive to use this type of graph. Just my opinion. All right, so you can see that by not specifying y min equals length minus standard error, we have in essence cut out our error bar, or cut our error bar in half. How about we add jitter points to line points? We need to use the original data frame for the jitter plot and the summary df for the geom layers. So I showed you this above, but I just want to point it out again. ggplot, data frame, aesthetic, dose, and length, just like we did before our ggplot objects. We'll add our jitter first. Our position is going to be position. I have a hard time typing position, huh? Position jitter 0.2. Color equals dark gray. And remember, the jitter just kind of spaces out the points. They're not all on a line, so you kind of see them. Geom line, aesthetic group equals 1. Remember, we do this if we only want one line. Data equals df dot summary. Geom error bar. Aesthetic y min equals length minus standard error. Y max equals length plus standard error. Alright, let's add data equals df dot summary, because we need our standard error from that df summary data frame and not from our regular data frame, because the standard error values aren't in there. Width equals 0.2. And let's add points. Geom point data equals data frame summary size equals 2. Or not add points, let's make it a point graph. So we're adding a line to our point graph, we're adding error bars, and then geom jitter. Point. Object D not found. Where did I just put a random D? Oh, size. How did that turn into a D? There we go. Okay, so now we have our line graph where the, let's make them, I'd probably add, what is this supposed to be? Yeah, data equals df summary size equals anyway, so this line, where the line intersects the error bar, is our average of our distribution. You can see the points throughout our distribution. The standard error here is our error bar. So I probably wouldn't use a line graph for this data, but if it was like time series data, where you're, 0.5 minutes, 1 minute, 2 minute, or something like that, where you're looking at how things increase, you might be able to use a line for this. Although I wouldn't use, I'd make this dose into an actual number instead of a factor, because the distance between 0.5 and 1 and the distance between 1 and 2 is the same, and that's not accurate for numerical data. But anyways, okay, let's keep on keeping on. All right, so the jitter points are kind of nice because it shows the distribution. I like them. I think they're a good way to display data. what about adding jitter points to a bar plot? Can we do it? Yes, we can. ggplot. df. Aesthetic is dose and length. You're going to be typing that in your sleep. Geom col data equals df.summary. Fill, we're going to say is NA. And then our color equals black, so we're not going to fill it at all because we want to be able to show the geom jitter points. Geom jitter. Position equals position jitter 0.2. Color equals dark gray. And geom error bar aesthetic ymin equals length minus standard error. Ymax equals length plus standard error. I see again that I'm not using the equal sign when I should. And then lastly, data equals df.summary, and we'll say width equals 0.2. All right, so we should, hey, that one worked first time. Look at that. So we have our bar plot with our jitter points. We could probably space out the jitter points a little bit. See if I make it bigger if they're spaced out. Well, maybe too big. You want to maybe like this. It's almost to the point where you can't tell. 0.3. Maybe 0.2 was good. But so we got our error bar or our bar graph that shows us where things are. If we put a fill, it would cover up our jitter points. That's why we don't put a fill on for this one. You see our standard deviation. We know that they're significantly different. Our standard error, excuse me, we got our error bars plus and minus. You could probably just use plus if you wanted to for this one. You could change your colors of these, of your jitter points, if you wanted to, if you wanted to pop. Yeah, so you can play around with any of these things where it's like, you know, sizes, widths, mess around with them, play around and see what looks good to you. These are just what I've picked. I am by no means the, you know, person that commands how you graph things. I'm just teaching you giving you the tools, and you create the graphs that you want to create. I just ask that you try to be, don't try to be too fancy, because then you can lose the forest for the trees, as they say. And so, okay, moving on. What if we wanted to have our error bars per group? So we'll say OJ versus VC. Oops, ours goes inside there. Library, or we already have dplyr open, so we don't need to open that again. df.summary 2, so we're going to make another df summary, is df. And then we're going to say group by dose and supplement. Because right now we just have, this is our average for 0.5 of OJ and VC, of 1 of OJ and VC, and 2 of OJ and VC. So what if we want the 6 groups? The 0.5, 1, and 2 of OJ, and the 0.5, 1, and 2 of vitamin C. Summarize. SD equals SD length. Standard error equals std.error of length. You could put NARM or NA.rm equals true. I don't think we have any NA in our data, so you don't really have to do that. It's good practice though. Summary 2. Alright, so now let's run this, and we should have 6 groups, right? Yep. We've got 2, 4, 6. We have our standard deviation, standard error, and our length for 0.5 OJ, 0.5 VC, 1 OJ, 1 VC, etc. Okay. Now you can see we have mean and error for each dose and sup. So let's graph that. ggplot ef.summary2. Aesthetic is dose and length. Geom point range. We're going to say our aesthetic is ymin equals length minus standard error. Ymax equals length plus standard error. Our color is going to equal our supplement. So that's how we're going to separate them apart. Position equals position dodge. We'll say 0.3. That's what we used last time at the end of me messing around, and I thought that looked okay. And then scale, color, manual, so we can pick our colors again. Indian, red, and light blue. Okay, and go. Okay, so you see that now we have a OJ and a VC for each, and so you can see that if we compare the supplements, or within the group, so we had a higher average for OJ at 0.5 and a higher average for OJ at 1 compared to VC. But at 2, since these error bars overlap, there's no significant difference. So that's what this is trying to convey, this data is trying to convey. Okay. Now let's do the same thing, but change, oh no, sorry, we're already using standard error. Okay. How about line plots with multiple error bars? Okay, so ggplot df summary 2 aesthetic dose length plus geom line for a line plot aesthetic line type equals sup group equals sup. So we're going to have 2 different lines based on our supplement. We're going to add points. Geom point, and then geom error bars. Ymin equals length minus standard error. Ymax equals length plus standard error. And our group equals sup. Width equals 0.2. Okay, so we should. There we go. So you can see we have essentially the same graph, but we've made it into a line graph where we see that the VC is the dashed line, the solid line is the OJ, we have error bars. You can see these 2 error bars actually overlap physically, so you could say there's no significant difference once you get up to 0.2. And the same with a bar plot. We're almost done. This is a long one, but we're getting through. df summary 2 aesthetic is dose and length. Geom col for a column graph. Aesthetic fill equals sup. Position equals position dodge, because we can't have our stuff overlapping. I'm going to say 0.8. And our width equals 0.7. We're going to say geom error bar. Aesthetic ymin equals length minus standard error. Ymax equals length plus standard error. Group equals sup. Width equals 0.2. Position equals position dodge 0.8, and then, oops, this is a plus, and then, wait, it should be back here. Scale, fill, manual, values equals C, Indian, red, light blue. Something's off here. Okay, I figured it out. I can't spell position. I misspelled it twice in my previous one. I believe on both the position dodge ones here. So position, now it makes more sense, right? So we have our error bars and our two different graphs. Before we had, this was our comparison, but now we have them as bar graphs. Okay, so now let's add some jitter points to make it look real nice. ggplot, df, as, dose, length, and our color is going to be supplement. Geom, jitter, position, I gotta be careful, position equals position dodge. 0.2, geom, line, aesthetic, group equals supplement, data equals df, summary 2, geom, point, and geom, error bar, aesthetic, ymin equals length minus standard error, ymax equals length plus standard error, and then we need to add group equals sup, data equals df summary 2, width equals 0.2. Okay, let's run this guy. Not a fan. So we have jitter points on our line graph. Let's do one more. Last one. Okay. ggplot, df, aesthetic, length, dose, length, color equals sup. Geom, we'll do this as a bar graph. Data equals df, summary 2, position equals position. Position dodge 0.8. Width equals 0.7. Fill equals white. And geom jitter. Oops. Position equals position dodge. Position. Jitter dodge. Jitter width equals 0.2. Dodge width equals 0.8. And geom underscore error bar aesthetic ymin equals length minus standard error ymax equals length plus standard error. Data equals data frame summary 2. Width equals 0.2. position equals position dodge 0.8. This is a long one. Bear with me. We're almost done. Scale, color, manual, values equals whatever colors you want. Indian red, light blue, and then theme, legend, position equals, I'm going to change it. Well, I think it was always at the top, but okay. Look at that. This one looks good. The last one, I don't like the jitter points on it. It's too hard to read. But this is good, right? So you have 2 colors, one for our each supplement, OJ and VC. We have our jitter points. We have our error bars, so the non-overlapping error bars. Those are showing that they're not significantly, or they are significantly different, except for in this 2 range here. And in the jitter points, you can see the clustering down here and the clustering up here. Same here, but these overlap, right? So they wouldn't be significantly different. This is a long one, so let's get out of here, right? Okay, so that's it for error and jitter plots. They're really important to have. If you go to any sort of conference or place that you're going to share your data, if you don't have error bars in your graphs, people are going to call you out on it. Like, there's plenty of professors and other graduate students or undergrad students that are going to call you out on it, that have no problem, saying that your graphs suck. So make sure you do your statistics, your t-tests, students' t-tests, and correlations, if you're doing correlations and things like that. But error bars, very important. Now you know how to put them on every type of graph that we've run so far. And I'm not going to keep going because this has been over a half hour already. So I hope you enjoyed the video. If you're watching on YouTube, hit like, hit subscribe. Plenty more videos coming up with more data products. So stick around and I'll catch you in the next one.